Okay, a very big welcome tonight to Denby Dale Amateur Radio Club, and we're delighted to have Bob Heil with us again. Bob was with us last Christmas and promised that he would come back again, so really pleased that we've got Bob here tonight. And welcome as well to one or two new faces in the meeting tonight. As we said, as people were coming in the room, people are welcome to attend any of our online meetings. You don't have to be a member of Denby Dale, nor do we require you to join. You are more than welcome to attend and participate in as many meetings as you like. If you do like us and you enjoy the banter and enjoy meeting people and enjoy seeing the same people, of course, you're very welcome to join Denby Dale Amateur Radio Club. And a big welcome, of course, to our members and visitors from overseas, both from the United States, from South Africa, from Belgium, from Germany, and some other parts of the UK. So very welcome indeed. Bob, I'm going to hand the microphone over to you and let you take it away.
No.
Okay. Well, I really appreciate you asking me. I love coming to club meetings. This is number 256 that I've done via Zoom since February 2020. There's so much of the science of this great hobby that it just isn't passed on to us. So that's what I try to do here. We're going to do a couple of things. First of all, I'll let you know how I got into this, but we're going to get into phasing big time, and we're going to get into the wonderful pine board. This is a project that we did on Ham Nation a few years back, and there's been over 1,000 people build this, and we'll get into that because there's just a lot of information and a lot of fun to be had. So we'll get into that. But first of all, I started my amateur radio career, I guess you would call it, in 1956. I was visiting one of my friends who had got a license, K9DTQ, and he said, "You need to get your license," and so I did. A year later, I got a license, and that was back in the day when Gonsets were king. We did some of that stuff. But my very first one was this as a Harvey Wells, and there's an SX99 receiver. There in the left corner, I wish that would be a little wider on that picture, but unfortunately I didn't make it. That's a homebrew rig. I'd only been on the air just a few weeks, and I wanted to build something, and so I did. That was an article in QST, and it was a 2E26 on 6 meters. I was a technician for 17 years. And the reason that I never upgraded was I didn't need to. In those years, it was the largest sunspot cycle, and it was amazing. I would come home. I was playing the organ at the Fox Theater in St. Louis. I had quite a career as a 15-year-old kid, and I'd come home from playing the Fox and at 11, 12 o'clock at night, and I jumped on the radio, and wow, the bands were open all the time. It was fascinating. So it grew and it grew. I got into building. I became one of the first single sideband stations. There were only about 10 of us at this time that the ARRL knew of. I took a 10B Central Electronics and built a mixer oscillator and had my grid dip meter to do all that. And next thing you know, the station was really just in a couple of years growing fast. And so I love to build, and all of these wonderful things that we need to know about, we can share with you. One of my biggies is antennas. You have to have an antenna. But as I say, it all starts at the microphone, which we have that covered very well later in life as we did. But the antennas are so important. I had a little 3 element antenna about 30 feet high on the roof of our home. But my parents were very loving and they let me do about anything. Of course, I was financially doing extremely well as a 15, 16-year-old kid. Hardly went to high school. I went the required number of days. I was just fascinated with all of the electronics. And I had a local ham. He was a Motorola dealer. He and a contractor. These two hams came up and they put up a 110-foot roan for me. And on top of that was a spiral array. And that was a wonderful antenna. And that was for 2 meters. But for 6 meters, I had a spiral array. All of the elements are not horizontal and all are not vertical. It was built to try to help the fading. A lot of times when you hear fading, you think, well, his power went down or whatever. A lot of it because of polarization. And then you get into the phasing between those two. So when your signal leaves your antenna, it never stays in that plane. It's changing all the time depending on the atmosphere. And it might go a full 90 degrees or 180. But those are some of the reasons we have this fading. So I really got into it in building all kinds of antennas. And for 6 meters, it was pretty easy to do. I needed more power, so I built a Johnson 6 and 2 Thunderbolt. Give me 1.5 kilowatts on 6 meter sideband. And it turned out that we discovered that I was one of only 10 in the country at the time. But I had got in contact with the J-beam people, and they wanted me to do an experiment. Want to know how I liked my J-beams, and hey, I truly loved them. They work great. They said, well, let's see if we can't get something even a little better. Would you like to do the experiment? I said, certainly. So they sent over 128 elements of J-beam. The local FM dealer, the Motorola dealer, and the contractor. They put all this up. We had a spare lot beside our Victorian home here in southern Illinois. And that's a 40-foot roan and a 40-foot roan boom. Pair of pop pitch motors to rotate it. And it was just going crazy in those days. And I truly was loving all the experiments that I could do on 6 meters. That's one of the big deals is that it's kind of difficult to experiment on 20 meters antenna-wise, and so I got really into to building antennas and things, but I had taken a little about a 14-year-old vacation, so to speak. I got into the music industry and teaching a lot of your countrymen and doing their sound and their tours. And many of them, who it was Peter Frampton. I built the talk box. I gave him the talk box for a Christmas present. And that's a picture of it, a production line we had for them. Joe Walsh was another great friend. And so many that we traveled with. But I had totally lost track of ham radio for a good 12 years. Well, I came back to ham radio, and I'm going, what happened here? What happened to my great Art Collins audio? Because when I left, the audio was great. It was very articulate. It was very pristine, very copyable, and I just freaked out because that isn't what I heard when I came back on the air. What I heard were things like this. Just mushy and bassy. It was terrible. And I said, we got to do something about this. And so what we did is I started building a little equalizer, not knowing exactly what was going to happen. I built it for me. And it was a little 2-band EQ. I took some of the things that we had been doing in our sound systems. And it was published in QST. They had heard about it, and it became the cover award, got the cover award, and was the lead article in July of '82. So it's one of those things that was really high on the list of what I was doing at the time. And I didn't quite know where it was all going, but I sure was having fun. The main thing about the equalization is that none of the radios at that time had any equalization. And that was really sad because we needed equalization. The Collins radio, the reason it sounded so good is because they were very narrow banded. They only had 2.4 wide filters in them. And so, yeah, you didn't have to equalize a lot, but the signal wasn't as nice and bold as we all would like it. And so that's where the equalizer came in too. We could do some very cool things. Here's a listen. Pay attention here, because a lot of radios are only 2.4 wide, and many now are 2.9. But listen to the difference.
This is K9EID, and we're transmitting at 2.9K with. This is 2.4K, and as you note, it's nice and it's articulate, but the whole bottom end drops out because of the filter network. We'll go back to 2.9. Now this is the 2.9, and it's much smoother, has much more fidelity.
And that's why a lot of the early radios, some of them were only 2.1. And so as things progressed and the manufacturers started to put wider filters in there, well, here comes this character from Illinois, and I was building some very nice sounding microphones. And if you plugged them into a 2.4 bandwidth of the transmitter, they sounded like that. People would they would call me once in a while. What's wrong with this microphone? It doesn't sound very good. It had no bass. No, it's not the microphone. It's the transmitter. Now it's very difficult for a lot of people to understand, but that's a great. It's a great demonstration about bandwidth. And pay attention to this one more time. This is cool. There's a lot going on here. Go on. The filters in the radio are the key. Oh, you're not going to play for me. Okay, well, that's all right. We played it. So you want to pay attention to the bandwidth. When you set down to your radio, what are you going to do? If you're going to do contesting, you probably want that. So that's very important. Well, my life kept going, and we got into a lot of things. As I said, I was off the air all those years, but when I got back in, it was 1976. A couple of the local people, hams, or not even hams, they were CB operators that came to me, and they wanted me to fix their CBs. Well, I didn't want to get into that, but, when you had a soldering iron and everybody kind of knew that you were around, that's where things got really crazy, because they discovered that there was this guy with a soldering iron. So, what are you going to do? Well, I enjoyed building and I enjoyed helping them. But what I did, I took one of the CBs of one of my good friends and I started looking at it. You know what? If I changed a crystal and I did a little realignment, I could end up with a transmitter on 10 meters. I went further. Motorola had just come out with a chip. It was an FM demodulator. And we built the printed circuit boards for them and a pair of crystals to switch it so you could work the offset for repeaters. What I came up with was the FM10. It was the first commercial FM radio transmitter for amateur radio. And it was based on a high gain 5 circuit board. So I had heard that high gain was going out of business. And I contacted Andy Andros, who was the owner of High Gain, and I asked him, are you really leaving? Yes, he said. I said, well, do you have any of your radios around? I have a semi-truckload of boards. We're going to either toss them or do what. I said, can I buy them? And so I did. I don't know how many thousand were there, but they were high gain boards already aligned on the CB band, and all the wires color coded were there. All you had to do is put the band switch, the volume control, the speaker, that kind of thing. And so I built the kit. We built it was actually Tentec built that for me. Tentec had a great company building cabinets for all kinds of people, from MFJ to who names it. Well, they built a lot of stuff for me in the day. That's no longer there, of course. But the FM10 caught on big time because we had everything. We had the meters and all of the things. And I wrote the book on 10 meter FM, and many of the periodicals and people that were writing about it, they governed me as the founder of 10 meter FM. I guess it's true because shortly after that, I met up with the lady that was the president of Icom America over here in Seattle. And she got involved in that, and she wanted one of those, so I gave her one of the built FM10s. And the next thing you know, she calls me to talk about putting FM in the Icom. And so the history will be there for you. The 735 Icom was the first transceiver of any manufacturer that had 10 meter FM in it. And so I had a lot to do with that. And it was all over the fact that I was very well published in those days. But what am I going to do? I get back into single sideband. What are we going to do? We got to do something. So I started working with that equalizer, and that really started a big deal. And it's quite a story here, and it gets into the fact that Icom had sent me a letter, the president of Icom, the founder, CEO, whatever, Dr. Inouye. And in that, he had a picture. His station was one of the IC 781s, incredible piece, and one of my Goldline microphones, and one of my equalizers. He had one of the equalizers that he had bought. And so he wanted to know if I could look over their shoulder and see if they were going to do it right. And so from the Pro 1, Pro 2, Pro 3, all the way through the 705 has our equalizer in it. Yaesu did another one. They came to me a year later, wanted me to help them, and I did a parametric for them. The biggest problem is trying to help people adjust them properly. A lot of people just leave it in the default mode. Nah, it's not good, only because you don't know how to do it. We're going to take a couple of minutes. Watch how simple this is. The first thing you do when you sit down at your transmitter, what do? You have to figure out where are you going? Are you going to do rag chew? You're going to do net control? You're going to do DXing? Because that all has different equalizations, different audio. And so you figure it out. If you're going to do rag chew, well, let's figure out what you're going to do for that rag chew. And it's very simple in that all of the Icoms, they'll have different maybe looks on the screen, but they're the same. The very, very first thing you do when you touch the radio is set up the transmitter bandwidth, TBW. Again, we're going to do rag chew. So we're going to set it at 100 on the low end, 2900 on the top end. You go up to the equalizer. You're going to roll off some of the bass. You don't want a lot of bass. And -2 or 3. The treble, we want a lot of it. 2.5K. That's where the sweet spot is. You remember that and never forget it. 2.5K. That's the magic spot. And I have a nice little way of helping you remember and kind of embedding it in your mind. We're full range here, no EQ. What you're going to hear, I have a parametric EQ, means I can change the parameters of the filter. It's not just bass, mid, treble, but it also has a way we can change the frequency of the bass, mid, treble. We're only going to deal with the mids, and I'm going to remove 2.5K. Listen what happens. The essence of sound, the spirit of sound. It's so articulate here. The F and the S, they're so clear. Here's what happens when you don't have 2.5. The essence of sound, the F and the S, they all mush together. I haven't changed anything except I took out that 2.5 slice. I'm going to put it back in. I'm not changing anything. Here it comes. There it is at 1,000. Here it comes at 1,500. And when I hit 2.5, you're going to know it because it's just beautiful right there. That's 2.5. And again, we have the F and the S. They're all there. And so you have to pay attention to equalization. In the beginning days of equalizers that I brought to the market, so many guys, I don't need that stupid EQ from high. I don't need that. Yes, you do. Yes, you do. You need that articulation. What happens if you're a DXer? Well, we do something even more radical. We set the bandwidth at 500 to 25. We're rolling off everything under 500. You don't need it. It doesn't do any good. It doesn't help you with any articulation. In fact, it muddies it all up. And you want to get rid of that. So we're 500 to 2500. And then you go up to the equalizer and you roll off all the bass that you can possibly garner. It's gone, -5. And we're going to +5 on that treble. Those two filters, Icom built those according to my specs of the EQ200. The bass is 160 hertz. The treble's at 2.5K. And that really gets it going, but it doesn't sound very good because all of the high fidelity is gone. And so you have to understand what you're doing. I don't care about that. But here's another. Don't look away. This is very important. Let's say the air in this balloon was RF. Now, if we do the rag chew, we stretch it out to 500 to 29 and have a little rise at 2.5. However, for the contesters, we're narrowing it up. We're chopping off the top and the low. And we opened that 2.5K wide open. The only escape for RF, because we narrowed it up, is at 2.5K. And now, all of that articulation that is so important is right there, right in your face. So that's very important to understand. And we were also commissioned by Icom to build a proper microphone. These companies all don't build their microphones. They're all imported or they're just OEM things. And you just don't want to worry about that at that time. So we had to do this to make a microphone for Icom. and we did. Call it the ICM, and it's really great. It only works on Icom. It won't work on anything else. I love this microphone. It's on our lighted base, but it's got a push-to-talk switch. Comes with the cable, so you can't plug it into anything else. Well, you can plug it in, but it won't work. So that's all part of that. But I'm so thrilled that things really took off with Icom when we got to working with them. It was a lot of fun. So I'm looking forward to having more and more things with the various companies, because we did some things that none of them have really done. But we want to get into our pine board discussion today. Nick wanted me to get into that a little bit. You know, the pine board was a remarkable thing. When we started doing that on Ham Nation, I never realized what was going to happen. You know how I am about building, huh? I want everybody to build. So I thought, this would be a nice way to do it, maybe. And it all started, and this you guys and gals might take a little lead from this. We have an AM net every morning at 9 o'clock. And that AM net runs all week long at 9 o'clock. On the first Mondays, we call it the peanut whistle net. That means that only those that are running a watt to 10 watts can join us. So it was a lot of fun when we did all that. And so many people would get into it, and then we started building. The first thing that I did that was really crazy, I built a preamplifier. It was a microphone preamplifier. Actually, is a preamplifier out of a Fender guitar amp, a Fender Twin. And again, I love to build, and I'm just messing around, so why not, And it was one of those things that I just truly loved, all of the things about building and sharing it. And Ham Nation was the place to do it. And so we started off, we'd take a project one by one. In other words, there's the microphone preamp, but you'll note it has equalization in it. Of course it did. And then we built a power supply and went on to build the final. And when we put it all together, that's what you have. And it really caught on. As I said, we're over 1,000 that we know of. And how we know that is Antique Electric Supply in Mesa, Arizona have kits. They made the kits for us. The pine board power supply you'll see there in the upper, the pine board microphone equalizer preamp, and the final. Just worked great. And the big deal is this. We had to have diagrams. W4IQN, he is a retired graphic artist from General Motors. And look at these diagrams. They're better than the old Heathkit. And if you guys and gals were around in those days, those Heathkit diagrams are great. These are better. They are much better. You didn't even have to read a schematic. And it all started off with just raw pine board. And you could make it happen. And when we got all finished, why, there we are. That's where we're headed, right there. And it was really wonderful to be able to build this. Now, what you're looking at there was a little bit of an adaptation that I did. That was one where I built or made the outboard power final longer. We'll get into that in a minute. And that one is band switching. It band switches from 75 meters 160 meters and 40 meters, all three of them. And it's just wonderful. But the main thing is that it was so simple to build. And we'll go back and I'll show you what happened with the power supply. We started out with the diagram, but then you take a piece of raw pine board, whatever kind of board you have, and install the terminals, and we have pictorials of how to do all that. Then you mount the parts, and away you go. So this became that. And we, of course, have all of the parts listed for you, but you can go to Antique Electric Supply and buy the whole kit. All of this is on my website. I'll share that with you. But I wanted to get in with the Pine Board mic preamp and two-band equalizer. You heard how important equalization is, and so away we went. And it really performs well. I've had a lot of guys build just that to put in front of some of their solid-state rigs because the preamp is really good. And we have a thing I added to it down in the bottom. You'll see a little red switch, a couple of caps we added to it. That gives us a bright control so we can increase the treble even more. And that's wonderful. It's very, very exciting. We can do these kind of things, and it's so easy. And we have other things we can do with that input. If you are using high impedance microphones, well, you go straight in. I think it's 100K on the front end. You go in through the input, but the input, if you have a balanced XLR, go in through a transformer, and that's how you do it. It is that simple. It is that simple. And there's the diagram of how it does. And there's the layout for that. And that's where it all starts. Once you do this, it's great. Now, since you can't get to the bottom of it like you would in a regular chassis, here's the simple way of doing that. This is the 12AX7, and that's the microphone preamp tube. There it is right there. We take all those components around it and mount them on the back of the tube socket, and then we put risers on it. You can make your risers or find it, and it gets it stand off about an inch or so. And that's how you build the pine board stuff. It's really quite simple, but it makes a lot of sense. I mean, it makes a lot of sense because here you've gotten all of this together for the ground paths. Going to do that. And as I said, if you want to do your transformer, you could do that or just use a regular jack. But that's all you need right there. A blank board. Wire those components on the back side, and it's wonderful. It's very simple. But then the transmitter, each one of these projects would take many months. The transmitter took maybe 4 months. We only did about, maybe 10 or 15 minutes each program. But finally we got her done. And again, we started off with Gene's great drawing. There's the schematic. Does that mean anything? That really means something. You know exactly where everything goes. And there's the parts list for it all. And when you put it all together on the board, you're ready to fly. So it's very simple to do. And there's the other, that's the bottom side of those finals and the modulator tubes. Mount all that, away you go. Here's the bottom of the final tube. And then you mount it all and then you're done. But it sure does work, and it's so simple. Now, you see that little indentation in that clip. It's kind of hard to see it. Here, this will be better. That's the band switch, everybody. That coil, the full length of that coil is 75 meters. And if we want to go on 40 meters, you change the crystal. It's up in the right corner there, the crystal socket. You change the crystal and you take that little alligator clip and you short out the last of the coil so that only the short end of the coil is resonant. And that's how you get two bands out of one. And I know it sounds silly, but in your new radios today, that's all that happens when you go band switch to band switch. It's just shorting out things and different coils for each band. And that worked really well. We had a lot of fun putting all this together for everyone. I didn't show this earlier. There's the band switch. I went one step further. I used the full coil. You see, that coil came from MFJ. We couldn't find a coil, and you could wind your own, and some guys did, of course. But MFJ will sell you anything they have, parts-wise, and you order their coil out of their 811 final. It's 160 meters, and you use the whole coil, and then you tap it so you can short it two different places to get it to 75. Only here, I did it with a switch. It's sitting on 75 meters right now. If I move that up a little, it's on 40 meters. If I do it down to 160, and that's doing the shorting of the various coils, and it just works so well. I also put an antenna relay on this one. These are all things you can do on your own, and very simple. There's the diagram of that. And the other thing is, hey Heil, how are you going to mount a coax connector on pine board? Well, you do it like that. You take about a number 16 piece of copper wire and you make a little U shape, and that goes onto the coax connector and then attach it to the board. It works great. Just have to think a little bit. Now, there's the working model on 75. When we got the word from QST that they were going to publish this, they said, but we're going to have to certify that. I said, what are you talking about? Well, you have to be down 35 dB on the third harmonic. And I said, now, wait a minute. How are you going to do this? Well, you got to ship it up here. That's not going to happen. I didn't build this to bounce around in the back of a UPS truck. Well, there's one of my good friends on my morning net, WB40JM. He's a retired certification engineer for the U.S. Army. He's got more equipment than you can think of. And I went and visited him one day, and I took my pine board. He said, well, hey, we can certify it right here. And so he did. And that was amazing what he discovered when he put the things all together. We're looking at it on his spectrum analyzer. And it was something. Just one of the screens. But you'll notice the third harmonic over here was down 52 dB. We were both astonished. My gosh, you gotta be kidding. That from that, yeah. And so the ARRL took his certification numbers and I didn't have to ship it. And so it became the cover award and all that I told you about earlier. And away it went. So we were very honored and kind of blessed that all this happened because so many people are building this and it hasn't stopped, I'll tell you that. And so we're so happy that it's really gone on. Here's some examples. Here's a couple of guys that have built. This was one of the originators of the peanut whistle net. He's a retired TV broadcast engineer, and he's the guy that really got me into building on pine board. And here's something from another guy that built the pine board. He's a very experienced builder that built it out of a chassis. And I wanted to do that, but it gets tough. You got to do metalworking on it. We can do it just as well. See other examples. There's a guy to build a tower with the power supply, and that was very cool. And I still receive things today from people. And then you get, well, where are you going to buy vacuum tubes? You can buy tubes all over the place. Especially these are very, very ready. Antique Electric Supply has them, or you can do vacuumtubespot.com. That works great. And if you go to my website, heilsound.com, and when it opens up on the ham radio side, we have the Pro division and the ham radio division. When it opens up, you search for Pine Board Project, and there's about 50 pages, all these pictures and diagrams and things that help you. And that it's really a worthwhile thing for all of us, because we should be building. We really should be building. And I love sharing all this. Well, I'm going to walk over here. Let's go check this out. Show you what we're doing here. First of all, we're going to turn it on. Now, here's something that you want to be aware of. And this is something that every day when we started the project, every day before we did anything on the show, we told everybody to respect high voltage. There's some of these have come out, depends on your transformer, could be about 450 volts. So remember, this is the bass and treble. This is the gain for the preamp. There's that switch for the high boost. It gives you a little bit more treble. It really works. This is the mod transformer. This is the modulator. That's the final. Well, let's see if you can even see this. I think it's up. We'll find out. I've got it on 75 meters, okay? And we have the crystals are already installed. That switch, that's a 3-position switch that's switching the crystals. It's also triple pole. It's switching, yeah, you can see that. It is switching the taps on the coil for 160. This is for 160, the whole coil. This one's for 75, and that one's for 40 because we're only using that much. That's how simple this is. There's the relay for the antenna. There's another output in the back that your receiver would plug into. Okay, I hope this works. I haven't had this on the air for 2 or 3 weeks. There we go. Let's tune her up. Oh, hey, that was pretty good. It was right there. Yes, I'm using a light bulb for a dummy load. Why not? I mean, why not? I have a lot of people say to me, well, why don't you use a dummy load? Well, I have a dummy load, but isn't it more fun to do stuff like that? That's the way we did it in the old days. I'm an old dog. Pulled my mic cord apart. MFJ makes a really cool little, it's a QRP dummy load and watt meter, but that's the way she goes. Let's see if we can get on 40 meters. There's 40, and we gotta find 40 meters. It's gonna be up here probably. There you go. And I got my 160 in there. Come on here. Down 160. There's 160. Isn't that cool? Yes. And it's so much fun. It is so much fun. And what I discovered, people would build this, and they'd send me emails about, they were like shocked. It worked the first time. Well, a lot of that has to do with those diagrams. You didn't have to read any kind of a schematic. I'm going to put this in the rest position. You didn't have to read schematics right off. You can build it right from the pine board and all of the things that we did for it. So that was kind of fun for me, to turn a lot of people into building. And the Pine Board Project certainly did it. And if you go to our website and search Pine Board, you'll find a lot going on. Well, we have to get into antennas. So let's talk a little bit about one of my favorite subjects. Some of you might have seen some of this before, but there is never too much told about phasing. It affects everything we do, and yet you never hear about it. And it's like, what is going on here? How did the carrier get deleted? You see, Wes Shum was the guy that brought ham radio, a sideband to ham radio. And let me do something here. For any of you that are good book readers, I want you to go to Amazon and buy this book. It just came out last week. Wes Shum, do you know him? You should. He's the guy that brought single sideband to ham radio. If you had a trivia contest, you'd probably say, well, it was Art Collins. No, it wasn't. He was 6 years late to the party. He actually bought one of Wes Shum's kits. Wes started in 1949 building kits, going around to local ham fest in the Midwest. That's how it all started. And Art Collins bought one and he couldn't make it work. This is a true story. Wes told me this himself. And he had to help him because he had something wrong, or I don't know exactly what, wired wrong, whatever. Anyway, how did Wes get rid of the carrier? How did the other side, the only single sideband, how did they get rid of that? How does your notch filter work? If some idiot falls on your frequency when you're in a nice contact, he don't care about you. What do you do with him? You push the notch filter. How does that get rid of him? How does your Yagi work? There is so many things. So many things. That is all about phasing. How does your noise canceling headphone work? How do the equalization filters work? It's all about phasing. I have a wonderful demonstration for you here. I don't play any games. I want you to see exactly what I'm doing. I'm going to unplug this. And I have a Y cord, so I can plug two microphones in at the same time. These two microphones, by the way, are our PR22s. I got to adjust the gain on this thing. It gets a little crazy. Okay, there. Now, if we have two signals in phase, they increase 3 dB. There they are. I doubt if you can hear 3 dB because the human ear cannot detect that level. Oh, it's there. 1, 2, 1, 2, but not together. In phase. I have this magic little plug that I built. This magic little plug. Pin 3 is hooked to 2, and 2 is hooked to 3. I'm going to plug it in here. Come on here. Well, hey, Heil, no big deal. It still works. Of course it still works. When I talk into this one that's in phase, the diaphragm goes down. When I talk into this one, it's out of phase because of this. It comes up. 2 signals out of phase. What happens to it? Ready? It cancels. Nothing. Nothing. It cancels. The audio cancels because one's up, one's down. It gets more in depth, but it's a simple way to get you to realize that this phasing thing is really important. Let me unplug. And it's always bugged me that you don't read much about this. Why? I mean, we have all these great companies writing books or whatever. They never mention this. It's important. How does it work? You just found out. 2 signals out of phase, huh? Are in phase. How did your Yagi come about? Dr. Yagi, how did he do that? Huh? He didn't have any modeling and all that nonsense. He had a bunch of aluminum, a resonant dipole, and a field strength meter. He took the field strength meter out in front. Good, let her go. Now, he puts a signal in there and he starts playing around, quarter wave, half wave, so on, in front of the driven element. And in the right space and the right length, he could get a little gain. No batteries needed. Wow, this is amazing, isn't it? What about the rear? Well, it's the same deal. He can make it longer, and in the right place, it is out of phase and it will reject what's coming back because it's out of phase. The one in front was in phase. You can do this very simple with dipoles. I did this a few years back. I wanted to do this experiment because I've always heard about phased arrays. And so I put up a pair of 64-foot telephone poles. I got them from the electric company. They gave them to me. They have a lot of like 80 and 90-foot poles, and they get rotted off and broke off, and so they're just laying around. They'll be glad to give them to you. Get rid of them. So the antennas were 64 foot apart and 64 high. Again, 75 meters. The down lead length had to be exactly 126. Exactly, 126 foot, both of them. Then they couple into a T, and what couples it all together is what you see in red. That's a delay line of 43 foot on 75 meters. This was 500 feet from the station shack. And so we had a remote relay that we could switch it either to the left, which meant that was the driven element, and what was behind was delayed and it's out of phase. So you would get rejection. Wow, that's pretty neat. Rotate the other way, you're going to the other end of the spectrum, east to west. Pay attention. This is really cool. This is really cool. We have just completed the installation of a 75-meter phased array antenna system, consisting of a pair of coaxial dipoles mounted atop a pair of 55-foot telephone poles. We put them in an inverted V fashion, and the poles are 64 foot apart. These are 500 foot from the operating position, fed with RG213. In order to make the antennas directly from east to west, we use a delay line of 43 foot here on 75 meters that's switched in and out of the driven element, either east or west. The downlead length is 126 foot. We take all of that coax, the downlead length, the 43 foot phasing delay line, and mounted them in a container, one of the plastic container boxes that we actually buried, and just the top of it shows. It's all sealed, so it's waterproof. But that's the way we get to switch all the components from 500 foot using one of the Amatron RCS 8V remote switches. It really works well. Take a listen to how we can get at least 10 to 20 dB difference east to west.
Like a lot of people do, mine's usually 3 inches or so. That's just after I get done mowing it. And I know, probably, we get a dry day. I'm gonna have to lay out there and mow. That's just all there is to it, because if you leave it that high, when it starts growing in it all, it gets looking ragged pretty quick. So it's to that point now, and.
The system really performs on weak signals. Take a listen as we switch to the direction they're coming from. Also note the preamplifier makes no difference on 75 meters on this signal. The preamp will of course make the meter read higher, but in many cases the preamplifier does not cause the weak signal to be more readable. Check it out.
I see they introduced big display on it, and I don't know if that is their form of portable, or what that is. You go wide, and that hooked up to your computer, and then did you use your handheld to go through it?
Bob, we've lost your sound.
It's pretty simple to make that work. And I did it because I wanted to work my friends on the West Coast. And when I would do that, the East Coast stations or the Europeans would cover them up. And this helped a lot. It was amazing. And it didn't cost much to do it. I use the Ameritron switcher for the 75. I also put up a 40. It's up at 33 foot between those telephone poles. I did a messenger line, and I used a DX engineering box there. But the thing is, I don't like rotary switches. It got a little crazy. So what I did is I went to Antique Electric Supply and I bought a bunch of Les Paul guitar switches, and that's how I switch them. Here all the guitar switches switch to different antennas. The colored ones switch all the different radios. There's 6 radios here that we switch it all around. And then there again, it's all fun stuff. And we've done a lot of things like that. My other experience with, I guess it's all QRP stuff, is how many remember this? The Amico. This is amazing, this little box. It came out in the early 60s as a kit. Well, it's back. This is a brand new kit. I put it together maybe a year and a half ago. And my soldering pretty good, I think. There you go. And it's for CW. But I said, wait a minute. I have a modulator for my ICO stuff. So I took my Greenlee punch and I punched a hole in the back and put an 8-pin socket. That's a jumper right there. And all you have to do is insert that in series with the B plus line feeding the final amplifier tube. It's real simple, but you can use that on AM and it works really good. I get about, 6 or 7 watts. And if you want to get crazy, I've got a Central Electronics 600L that will take usually about 5 watts and make about 200 out of it. It's an AB1. 813 does good. And so those are things you can do. The modulator was built by ICO. I'm an ICO freak. I love ICO. You'll see it on that way over there, the ICO. But what you can't see is behind it, the modulator. Ico was big in the hi-fi business back in the, usually I think they started about 58. And they had Williamson feedback circuits and really nice, high fidelity, clean, distortion free. Well, they took the output transformer that fed an 8 ohm speaker, put in a high impedance one at 5,000 ohms, and put that in series, and bingo, they added a 12AX7 and preamp, and you had a great AM signal. I mean, we're all, come on here. We're always talking about that on the nets in the morning. And there you can see the 600L. That's a sixer. Talk about another QRP. And then beside that is the Harvey Wells. That's my original Harvey Wells. I've had it since 1956. Original tubes. It works beautifully. It's still pristine. All of the gear I keep really nice. The 20A you see here, these guys right there on the right, that's a Central Electronics 20A. That's the one you saw in the early in the shots there. Built that from a kit. I was 18 when I built that, and just wonderful things. Again, building is something very strange. Also, is the receiver. You notice up on the top shelf beside the Ico is a little gray box, and a black, half of it's gray black. That is a Mosley CM1. In 1962, they built a couple of hundred of these, and Mosley's plant was across the street from the restaurant in St. Louis at the airport, where they were building antennas and stuff. I played the organ across the street from their factory, and every once in a while, once a month or so, I'd stop in there to see what Carl Mosley was doing. I went in there one time, and it's like, what are you doing, building receivers? John Clemens, who was an aerospace engineer, W0BD, he designed it and sold it to Art. And a few years ago, I became really good friends of him, and he just passed away last year with COVID. I am so distraught. He was quite a guy. But anyway, that's all of my old gear, and I use it every morning. There's another neat little one here. It's called the Mars. This guy. That is an amazing piece. A mobile transmitter, 5 watts, and it's 75 or 40 meters. And it's for mobiles. And mounted it underneath your 55 Chevy Dash or your Ford Dash or whatever. And I have it going, and I modulate that with my mic. You know, it's on AM. I modulate that to get a little more gain out of that mixer. You see, I need a little more preamp gain. But these are some of the things that really turn me on into ham radio. And last but not least, I do have to let you in on this one because it took me 2 years to do it, and I'm always so disgusted. I work for the companies, guys. I'm inside the big three plant, and I've constantly, over the past 20 years we've been working with them, I ask them, what are you doing about your receive? Oh, our receiver, fine. I'm not talking about sensitivity. I'm not talking about selectivity. I'm talking about audio, and they are terrible. Every one of them, even the $15,000 ones, they got 1 or 2 watts at 10% distortion. But you've never seen a spec sheet. Never. They don't publish it. I say they're embarrassed. They just push it on us and, oh, it's okay. Little junky speakers. Oh, I'm sorry, it's a matching. No, they take that junky speaker, put it in a box, and charge us a couple $100 for it. That's nonsense. I have to do something. I couldn't stand by. Paul Klipsch, the father of hi-fi, was a great mentor for me. And I used some of his wonderful theories of building speaker. We built thousands of speaker cabinets for the rock and roll industry for all those decades that we were doing that. But I turned it into this one. First of all, I had to find a very good speaker. Look how big the magnet is on that thing. It's a wonderful, very good speaker. Also have a 3.5-inch titanium tweeter. But is absolutely perfect. You take the speaker outside into free air. You find out what the cone resonance is. Then you build the cabinet to meet that resonance. So there's no distortion. There is no phasing problem. Because if it's not right, there's all kinds of phase distortion. Then the amplifier is 25 watts at 0.1%. This is hi-fi specs. Why would I want that much power? For headroom. You're only going to use probably 3 or 4 watts, but man, is it clean. Wow. And it's balanced line in. I don't use anything. All of our microphones now, most all of them are balanced line. And so are the transmitters, but you don't know it. This is what's sickening about it. The transmitters have a differential amp, but they don't use it. They use it unbalanced. But if you know how to wire it properly, you can make it happen. The first one I did was a Yaesu 9000. If you ever saw one or own one, God bless you. It's the best ever. It has all of the things that I designed, and Dr. Hasagawa did it. Got parametric EQ. It has no ALC meter. It has a meter that says mic gain, because that's exactly how you adjust microphone gain. A lot of people don't know that, and it's sad. And it has a balanced 3-pin input. In other words, when you look at the input, it isn't one of these stupid Japanese Foster plug 8-pin thingies. It's that broadcast specials. It's 3-pin, 600 ohm balanced. Well, they used it for that first one, and then they didn't do it anymore. But they kept the balanced input. Aha! And we know how to do that, because all of the cables that we build for our microphones use that balanced input. Icom's got one, Kenwood's got it, but they don't use them. They use unbalanced. That's sad. RFI, oh my God, you get rid of a lot of that. So here's the receiver. I said, we have to do something about this. The speaker was great, and I started out using the things as you see there with the speakers and all the amplifier. But then we got in to the meat and potatoes, as I like to say. I built the equalizer, but this equalizer is 3-band. One of them is on the low side at 160 hertz. There's another one on the top end at I'm trying to get this working here for you. Okay. The other one's on the top end. And then we have the mids. The mids, where are the mids? Well, it's parametric. You can put it wherever you want. And that's what's so important to make all of this work. The low side sitting at about 60. I'm all right. About tripped over my chair. The low side's at 160 hertz. The top end, that's at 6K. But then we have that wonderful parametric. There's the high. There's the low. This is the gain of that parametric filter. This is the frequency. You dial it up just like a radio, from 400 to 4,000 hertz. The other thing that I didn't think about when I built it, I thought about it, I put it in there, I didn't know it was going to be such a popular thing and needed, was the headphone amps. Headphone amps for this market is terrible. They're so distorted. They don't care. They don't think, you listen to a lot of noise, Heil, you don't need. That's what I get told by some of their engineers. Nonsense. These are all separate amplifiers. They are not Y-corded together, and they're very, very low distortion. This is for your logger. This is for your operator. But where it's really making a big play, this could be your left side of your headphone, the right side. So if you have a hearing imbalance, bingo, case closed. We're selling so many of these for people's televisions. Television has terrible audio, and computers. Don't even get me started about that. Computer speakers are junk. Then the other one is a separate line out that drives your computer for recording. Really works well. I have a recording that I did with using this out of an Icom 7851, and I did these on 20 meters. And what we're going to do, I'm going to set everything flat the way you hear it. And this is the gain of that. We've got to do that. But everything's flat.
I had a lot of fun the other night.
Let me get by here.
Well, I wonder if I can copy that.
There's a guy.
I had about 30 words a minute.
He's
so
real pinched.
I speeded up the tape, and
We can put
sure enough, I can
make
copy
him
it.
sound like a human. Here comes the biggie. Here's the way you hear this guy. Listen what happens.
Echo India 8 Bravo Lima Bravo EI-ATLB calling.
That's without the EQ.
4 Sierra Germany. Hope I have it right.
Again, that's how you hear him.
Name is Lima India Alpha Mike, over.
There it is flat.
CQ 20 meters. Echo India 8 Bravo Lima Bravo EI-ATLB calling in right.
Absolutely amazing. And I'm so proud of it because it's helped so many. I get letters weekly from guys very emotional that I gave them their radio back. Because, there's some of these things out there, but I'm sorry, they don't work very well. And this is a true parametric filter that is so helpful. And especially the headphone situation. Wow. It means a lot to me that so many of the guys and gals are getting more out of their radio now, and that means something to me, I got to tell you. But you can use it in all kinds of configurations, and that's what's important to me. Well, I'm just about to wind things up. I want to tell you a couple of things that you might want to look into. And that happens to be our cable connectors. You're going to say, what are you talking about? I'm talking about the fact that all the cables you have coming from these great manufacturers are pieces of garbage. Foster owns the patent, 1963, for the CB radios. Icom, Kenwood, Yaesu, that's what they use. The cable clamps don't work because they usually put a piece of heat shrink around it or some rubber tape, and it falls out before long. Well, I got tired of that, so I did something about it. And also, while we're here, you notice that red wire? You can open up your connector on the shield pin. You don't take it off. You add that red wire. It could be green or blue, by the way. When it put it all back together, make sure it's all connected to the cable clamp screw. What you are doing is grounding your shield because none of the radios ground their microphone shield. It's no wonder we have RFI problems. Think about it. That's the first thing you do is you ground that shield. They're not grounded in your radio. And you're getting by without any RF. That's great. So I said, okay, we're going to fix this. And so I did. This is a huge connector. Of course, it fits that. I had to go to Foster and get a patent release. You see how wide it is. So if you're trying to put it into a recess like a TS200 or something, you don't need a pair of needle nose. And we make our own wire. And it fits the cable clamp. When you clamp that down, you can pull your car with it. But there's a second one for our push-to-talk line out, so you can plug in a foot switch or a hand switch. The wire is amazing. all the wire out there's junk. It's 26, 24 gauge. This is 18 gauge. And it's very, very subtle. You don't have any problem with it. Look at the shield. It's 100% silver shield. And it's so easy to tear apart. Usually you do that and you end up with two little strands. Here you can end up with 100% of the strands. And those are two 18 gauge for the microphone. If they're balance line microphones, we need that. But what about the blue and the red? They're on the outside of the shield because that's where push to talk ends up. So we have DC on the outside, AC on the inside. And for all of our radio companies, they put all it in one. No wonder we have RFI. It's just crazy. But this and so many things we talked about today is in my handbook. If you don't have this, you might want to get it. All the dealers have it, or you can get it from our web store. It's things that I talked about, plus many, many others. I didn't write it, I compiled it. All of these great notes from my mentors through the years. We're the only company in the Rock and Roll Hall of Fame. I've been so blessed. And it's all because of some of the wonderful things we did in that industry for the Who and Peter Frampton and just on and on and on. And that's the first quad mixer I'm standing in front of that's in the display. We built that for Quadrophenia. And on the other side of it is a mixer we built for ZZ Top. We were the first company ever to build monitors, and that was all because of how I knew about phasing and the original talk boxes there. And a couple of years ago, I was awarded an honorary doctorate at Missouri University. It's just unbelievable that all of this happens with some little kid that barely made it out of high school. But it's all about ham radio, I'm telling you. So I really appreciate you having me. I hope that some of it is beneficial. I'm always available. All you got to do is send me an email. K9EID at ARRL. It gets it. I'll answer you back. A lot of times you'll get on Skype or Zoom if you have a real big problem. We'll help you. So, Nick, I really appreciate you having me, and I hope everything went okay for you.
Yeah, that was great, Bob. Really, really enjoyable, and some lovely memories as well from earlier days. Anyone got any questions for Bob or comments they'd like to put to him? Everyone's gone very shy now.
Just a minute. Go ahead.
Yes, go on, Gerald. Hang on, Bob's disappeared, but hold on a tick.
I'm on mute today. I'll wait till he gets back. But it's.
I'm here. Okay.
Oh, you can see it. Okay.
Yeah, go on, Gerald.
Thanks, Bob. First, it was a very, very interesting talk, that, and especially seeing all the old valve gear as well. But that's partly because I got into radio a long time ago. But just a question: do you think it's a good idea sometimes to have the receiver band frequencies different to what you transmit? Is it tend to want to transmit a wider bandwidth, but receive on a narrower one because of all the background noise that it helps keep out? Any thoughts on that?
Well, that's pretty possible with most of the rigs today, because you have a separate equalizer for the receive as you do the transmitter, and of course their receiver audio is not good. That's why I did the parametric system, because you can really get some things happening, as you heard. I'm pretty sure you heard that come across. That there is no argument that I have really tapped onto something strong here, and that really works for receive. And then we don't care what happens on the other side of the transmitter, and you can do narrow, wide, mid, whatever. But yeah, you should be able to do both of those, no problem.
Yeah, thanks. Yep.
Yeah, good point, Gerald. Thanks for that one. Anyone else with a question or point to Bob?
Yeah.
Just go on far ahead, Jeff.
Okay, thank you. Thank you very much, Bob. Fascinating stuff there. Just maybe a stupid question. You gave some settings for SSB about treble and bass and bass and so on. would that be more or less the same settings for amplitude modulation and for frequency modulation? Or is that a totally different story?
Well, for FM receivers, the little they won't have any EQ in them because FM transmitters have already pre-equalized things for you. And you will not gain very much with an FM transmitter with any EQ because it's already pre-emphasized and de-emphasized for you. I personally like to take those and put them into my parametric receive system because you can notch out a few things and bring up that articulation in the mid-range. So you can try that. But usually the FM transmitters have done it for you.
But for AM, for amplitude modulation?
For FM. You're talking about the FM transceivers.
Yeah.
On AM, you absolutely have to have equalization.
Okay.
Because most of the AM's pretty mushy and bassy.
Okay, does that answer your question, Jeff?
Yes.
Yeah.
Thank you, Bob. Great stuff.
Thanks, Jeff. Anyone else with a question? Yeah, Roger. Roger, you've got no audio.
How's that?
Yeah, it's okay.
Sorry about that. Hi, Bob. Thanks very much. Very interesting, as usual. I wondered about the phasing of the microphones thing. Did you just sort of discover that, or was it known and you just applied it? How did that come about?
I didn't
The
quite get
two microphones out of phase that you know, because you put speakers out of phase, microphones out of phase. Who discovered that? Did you discover it?
Well, all of this stuff I got from paying attention to the 1920s and 30s, especially 1920s. I didn't get into that here, but man, it's a whole show. Paul Klipsch, he was a master at all of this, and he came to visit me early in my career, and he pointed me to the 4,000 scientists at Bell Labs because they turned on the telephone system and it didn't work. It was all mushy and they couldn't understand each other. So what are they going to do? And they had to figure out some way. And there actually were 4,000 scientists that was put onto this subject because they were dying. I mean, here's the telephone system, got it all wired from East Coast to West Coast, and yet it was all mushy. What was wrong with it? You know, they thought it was all going to be flat. No, it's not. Your ears are not flat. Those scientists figured it out. The louder you listen, the more flat. That's why kids like to listen to music loud. But here's what they really discovered. And this is something that we all have to take home with us. If you don't take anything else home from today, maximum speech articulation is at 2.5K. This is exactly what the telephone system looks like. When they first started, they had it looking like that, and that didn't work. And then they discovered our ears had big holes in them. And once again, I'll do this for you. There it is, flat. Now what we're going to do, I'm going to take away 2.5K. And when I did, it just got muddy and bassy. The difference of an F and an S, a P and a B, there simply is no essence to that sound. I'm not touching anything except the 2.5K. When I get it up there, bingo, the essence of sound is stunning. And this has to happen with everything. Everything you own with audio is equalized. Well, it doesn't have any treble and bass. No, but the engineers have pre-equalized it inside your iPhones. All of your consumer electronics has some form of EQ attached to it so that it would be articulate. And that's where I learned it. I spent a lot of time. Paul Klipsch came to me. He wanted to see. I had at the time I had a 10,000 watt PA. I was out with the Who, and he wanted to see it, and he got me together with the Bell Lab studies, and that really changed my life because I learned a lot about it. Sure did.
Thanks very much, Bob. See you next year.
All right.
Brilliant. Thank you, Roger. Anyone else with a question for Bob? If I don't see you, then just start off with your question. No, if not, can we, Bob, very much indeed, thank you for your talk tonight. Very, very enjoyable. I think there's something in there for everybody, whether we've been in the hobby for a year or whether we've been in the hobby for 40 or 50 years. So thank you, Bob. Can we show our appreciation, everyone, to Bob?
Thank you. Thank you. As I told you, Nick, you have two options. I can walk over there and turn that on and play you a little tune real quick.
Yeah, do that.
Yeah,
great.
Definitely, Bob. Yeah.
Okay. Let me do this and we'll make it happen.
Magic. Electronic.
Bob, you've accidentally got muted. Can't hear me. Bob, can you hear me? You've accidentally got muted. We're going to have to wait till he's finished.
Sounded really good when it started.
It was excellent, yeah. I'm not going to say who is to blame for that.
But those of you who can do CW, just watch his fingers. Surely he can work the notes out.
Oh, yes.
I've got to say it, but his speakers are out of phase. Not in phase.
Well, if he's playing Handles of Messiah, we've got another 2 hours to go.
Yeah.
I can hear us. Say hello to Bob, quick.
Yeah, Bob, your audio got muted there for some reason. We only heard the beginning of the sound on Zoom.
That probably leaned on the keyboard.
Yeah, I think that's it.
Well, let me see what happened. Let's go see. We'll do a little bit more, just real quick. Okay.
Brilliant.
Love it.
Great, thank you.
Excellent.
Yeah.
Yeah.
A lot more of that.
Maybe next year he should give a concert, a whole evening concert of organ
Got a
music.
CD or something.
Yeah.
You know. Yeah, it's fun.
Great.
Lovely organ.
Yeah, absolutely.
Beautiful.
By the way, you can go to my website, and I think the CDs are on there somewhere.
Okay.
Really? Oh, thank you. Oh, great.
Miss Gracie is here for you.
That was brilliant. Thank you very much, Bob.
See you, Bob. Thank
Good night,
you.
Bob.
Happy Christmas
Thank
to you.
you, Bob.
And Merry
Happy
Christmas.
Christmas.
Merry Christmas.
Merry Christmas.
And Happy New Year.
Merry Christmas.
Bob. And these guys are going to bring absolutely everything science to insane.
Dan, how are you feeling?
I'm feeling very nervous. I've gone a
Good.